Okay, so I'm just going to give a start to talk about how to write Python programs. Okay, before we do any coding, let's look at an example why you might be asked to write a program. And so say for an engineer trying to build a smart light bulb, this could be a light bulb that connects to the internet or something like that. In your tests, you measure the lifetime of your new bulbs, the time, how many days the smart light bulbs survive before getting broken, and you find it to be 67, 8, 39, 36 days. And your boss goes, well, okay, how long do your smart light bulbs typically last? He really just wants one number rather than a big table of numbers. And how does the lifetime of our light bulbs compare to others for other companies? So this problem here is a kind of problem descriptive statistics. We have four numbers, and how do we define a number to characterize those four numbers? And this is sort of descriptive statistics. We also go further. So this kind of ideas, it's important to be able to summarize a collection of data. I mean, giving big tables of data to management is always a disaster. And it's useful for comparison purposes. You really want to know, you want to compare your numbers to either past measurements or other numbers from other companies. And so in statistics, there are ways to find the typical value of data set. And examples of this set are the mean or average and the mode or median. And there are also numbers that measure how spread out the data is. For example, this kind of estimate of variance and standard deviation. And this is going to be the kind of level that I'm going to expect of you. We're not going to do any deeper into statistics in this, but given that the motivation of this coding is sort of data science, we're going to just look at these. So we're going to look at the mean. So for this data set, I think a mean is completely fine. So it's kind of defined mathematically as the sum over each of the numbers. So I've converted this into sort of mathematics notation. But essentially, this symbol here means sum over, and I have an example. So if we look back at the numbers originally we had, we're trying to find the average of this because this kind of gives us a number to represent these four measurements. The first number is 67, then 80. Then we flipped, and we're kind of converting this into mathematics as x1 is 67, x2 is 80, and this mathematical symbol means sum I goes from to n, and in this case n is 4. And in the jargon, these knowns are the components of the vector. So a bit later, we're going to kind of code that up, code up the average, code up the mean. And I mean, just for information, although you've been taught all these things originally in school, there are other measures of central value of measurements, and one of which is the median, which just means you order all the numbers. So if I have these numbers 3, 4, 5, 6, 6, 7, 8, 9, 10, 11, 12, if you order them, then the middle number is actually the number that's the sort of characteristic of the central set of numbers, and the median is 7. And there's also things like the mode, which is the value obtained most often. So if I order my numbers and I find here that 666 occurs 3 times, 5 occurs twice, and everything else occurs once, so that means the mode is 6. And although you know these definitions, when you're actually looking at real data analysis, some of these different things like the mean, median, and mode have different characteristics. So there's advantages and disadvantages that you have to do in data analysis. Okay, but coming back to coding. So we've introduced, I know it's a bit early, we've introduced a bit of syntax. We've known how to write loops, do a bit of arithmetic, and then how do you write a program? So programs are created by combining the different components of Python: variables, loops, if statements, and print. In a sense, a program is a set of instructions you tell the computer how to code something up, how to do something. So at the moment, we're just learning the syntax of these things. So the way I would design if you're asked to do a task and you're thinking, well, how do I start? The first thing to do is try and solve a simple test case by hand. This is either using a calculator or just writing it on a piece of paper. And this will start to give you some ideas of how to proceed. Because then once you've worked out what the thing, how you'd work a calculation by hand, you can kind of start to then see what bits of Python you need to plug in. And usually you should do this for a small problem. I mean, if you're asked to write a code, we can ask you to write a code to compute the mean. So, I mean, I wouldn't do a test case with like 1,000 numbers. You could just do a test case with 4 numbers. And also the test case, when you've done it by hand, you can compare your output by doing it by hand or on a calculator with what you get from Python, and that will tell you whether your code's correct, or at least give you a good indication that your code's correct. And the other thing to think about when you do this is coding is like an iterative process. So, I mean, you should plan out your code and do things like that, but you'll also find that you write one solution to the code, and then afterwards when you look at it, you think, well, actually, I can improve this bit, and I can improve this bit, and it makes it a bit more flexible, and that's completely normal. And, you know, nobody writes the ultimate version of the code first off. So, but the first case is to kind of write down a test case by hand, and then actually code it up, and then see if you can improve the code. Okay, so we're going to take away all the all the information away. So we're just going to write a Python code to compute the mean of numbers. I gave a motivation why you want to do this, and you're asked to test it on these numbers. So this is all in a pure form. So this is now just sort of coding. So the first thing you need to do is convert the understand the problem to know exactly what to do. What's the kind of algorithm? So it says compute the mean of numbers. So then you look up, we had in the previous slides how the mean's defined. It's the, you sum up each part of the number, divide by the number of numbers. And if you can't remember that, you look at it from Notes or Google. And then you develop a test case. So here's the definition. We have 4 numbers, and our test case is 67 plus 8 plus 39 plus 36. Sum up all the numbers, divide by 4 to give us 55.5. And now we have this test case. We actually know that when we write our little Python code, we should get the same answer as this. And if we don't get that answer, we get the end that tells us it's wrong. I mean, there still could be problems with the code, but it's much better to have this little test case, and then you sort of have at least some inkling whether the code's correct. Okay, so this is the test case. I mean, this doesn't always give you exactly, it's not always completely obvious how to convert this into code, but if you break the problem down a little bit, you start off with, say, introduce this variable m, call it 67, then you add in the second number, then 67 plus 8 plus 39, and then add in the fourth number, then at the end divide by 4. So this well, if you break it down this way, you can start to see how you do this in code. And this, what this suggests is you need a variable m to store the sum. Also, when you look at these numbers here, you have this collection of 4 numbers that makes you think, well, I could probably put this in a list, and then the fact that you're doing this process, adding each one of these numbers in, suggests that you need a loop, which we introduced a bit earlier on. Again, I just want to stress, I don't need to see this working, but I certainly don't go through this process as much because I've been doing this a while. But if you're just starting out and you're thinking, well, how do I convert this problem into code? It's worth thinking out, how would I do this by hand? And then after that, think, well, what bits of Python do I need? Okay. Okay, so now let's look at the Jupyter Notebook. So what we're trying to do is we want to write some code to compute the average of these numbers. And from working the example, it looked as though you could put all the numbers into a list. And I said you need a variable here, m equals 0, to actually accumulate the numbers when you do the sum, because I have to have this sum. And then we want to loop over each element of the list. and that makes us think like a for loop. If we look back in example, here I had an example of running a loop, and you can. This is running over elements in the list, and then you think, well, if I modify this a little bit, where I can add up on little v under star, that will start to get me what I want, and that's what I have here. So I have m equals 0, and then we accumulate each element of the list, and at the end we divide by 4. Okay, so let's run it. Okay, and we get 55.5, which is the same as our test case. So that's good. So that means, well, I mean, this is a simple test case. Just the fact that the test case works doesn't mean things can't go wrong. But in this case, the code's simple enough that we know we're on the right track. Okay, and what I said, there's an iterative type thing. So this all works. But, I mean, usually these things, you want to make the code as generic as possible. And one of the problems here is I've divided by 4. For this list, it's completely fine. There's 4 elements, but it's not very generic code because this 4 is hardwired. You'd have to change it if you have the list of different lengths. And then in my second attempt, I think, well, it makes the code a bit more flexible if I write this ln. So it's the same code. I have a list. I loop over the elements. I add each element to the m thing that accumulates, and then I divide. And this len v is a function that just tells me the number of elements in the list. And you know, if you think, well, I don't know what, I can't remember what that does. Sometimes it's just worthwhile just printing it out to see what happens, and that will give you some idea of what the list is. Okay, so I mean, this example is, you know, we're just learning. I mean, a more Pythonist way to do this. There are, one of the things with Python, there's a huge number of libraries, and there's usually a library to do what you want to do. You still need to do some of this coding, but a kind of more Pythonistic way of computing the mean would be to use one of the Python libraries. And here I'm using something called NumPy. And so I wouldn't expect you to know this because we're only just starting, but just the kind of more Pythonic way of doing this is to put v into this NumPy, this library is specially designed for kind of arrays, and then we can just use the standard calls of the library. Right, and I've used this a little bit, so it might not work first time. Okay, I forgot to do that. Let's run that again. Okay, so I'm using a specialized Python library, so I just have to convert the vector into a sort of, I have to convert the list into a NumPy array, and then once it's in that format, there are standard ways to compute means. So the advantage of this thing is the code is a lot shorter. The sort of disadvantage is you have to really know about NumPy. But I mean, as later on, about 5 or 6 weeks, we'll about 4 or 5 weeks, we'll introduce this, and he'll start to learn some of the syntax. And the advantage of this thing as well, this could actually be faster because the code for running on v.mean is sort of optimized for faster computers. So I wouldn't expect you now to be able to do this, but I mean, also sometimes if you Google how to compute the mean, it'll actually give you sample codes like this. But and then you have to investigate what the kind of NumPy does. Okay, and this is also an example. I said the process of coding is sort of iterative. You start off with one example, and you can kind of improve it a little bit. So here we started off with this example where we had the 4 hardwired in, the 4 elements of the list v, and then the next example we made the thing a bit better by, okay, I've added some additional code here. We used the len v to make the code more flexible. Okay, so a key thing about this to know when it's correct is we actually had a test case, so we actually worked it out by hand. And this tells you, in some sense, when the code is correct. And working out the test case will give you some ideas of how to convert the problem into code. And the other part of coding is there are many small bits of Python that are typically used: print statements, lists, loops, for. And then it is, coding in some sense slotting in these different bits of for loops into something that solves the problem you're interested in. And the other important process about this is iterating it. So it's much like writing an essay. First you do drafts of something, and then you kind of improve the code. In some sense the code is good enough that it works and it's not too ugly, then you can kind of complete. But it is, coding is an iterative process. You get something to work, and then you work on it a little bit to make it more flexible. And this is also given a kind of fancy name called refactoring. Okay, so this is just a kind of process of improving the way you code. So it's also called test-driven development, where you start off with some tests, and then you develop your code to actually get the same numbers as the tests. So you can read about them all. So these slides are on the DLE. Okay, so you don't have to. I usually don't ask you to actually submit anything about the way you did the process. In the past, when I did computer science O-level, which is something before kind of something you get at 16, we also had to draw a flowchart before I wrote any code, and this is just some kind of diagrammatic notation. So first you convert the algorithm into a diagram, and having said that, I've never drawn a flowchart since then, but it is worthwhile just working out on a piece of paper what you need to do, or especially when you're starting out, to think, well, how would I do this by hand, and then use that to give you ideas of what bits of Python you're going to need. Okay, so we've already seen an example of NumPy, but actually when we get into coding Python a bit more, we'll see that Python has it uses libraries or modules, and that means you learn the basics of the language, and then actually to get stuff done, it's all a question of calling different libraries, and this has advantages and disadvantages. So we've already seen NumPy a little bit, which will do arrays and matrices. There's a module called SciPy, which is mathematical tools, what to do with things like matrices. We'll see a bit later called matplotlib, which is a standard plotting library. Rev, regular expressions, is Y for looking for things in inside strings, and then scikit-learn, machine learning, classification, regression, clustering, and all these things have functions, or they have routines to that are useful. And a lot of Python programming is combining different libraries together, if the truth be told. Okay, so we've seen Python. There are so it's a great language for many reasons, but it does have some disadvantages. It can be slow to run compared to C++. There are comparisons, and it is slow. One of the disadvantages as well, it's a very big language. You can do with a lot with a small amount of knowledge, but it is a very big language, whereas some languages are very small, just have a few statements, and also using all these different modules and libraries. And as we discussed yesterday, the use of white space to delineate loops can cause problems. And actually, one of the things you find that one of the issues is when we get into modules is so writing Python code actually involves using many different library functions, but sometimes as the modules and libraries get very complicated, if you install one library, it'll interfere with another module, and it gets to be a bit of a mess. And there are ways to deal with this, but it's still not really a completely solved problem of how to work with many different Python libraries at the same time. And I put I put this up as well, just because often you'll when you're trying to solve something, you'll obviously Google it and you'll get segments of code. So Python gets updated. There's a foundation that looks after it, and there's different versions of Python, and mostly they don't change that much. But there's a big difference between Python 2 and Python 3, and the amount of Python 2 is getting less and less. But you'll still see examples on the web somewhere. And the main difference between the two versions is the fact that in Python 2, when you write print, there's no brackets, but in Python 3, there's brackets. And I think this allows more control of formatting. It's a bit more systematic, but it does mean a lot of the code, if you use a Python 2 code, it won't work unless you replace all these brackets. Okay, and this is a kind of versioning issue, and there are much bigger problems with different versions of the modules and libraries where, code, quite often you'll load something from the web and try and run it, and then because you're using a slightly different input library, it'll cause you grief. Okay, that's all I wanted to say.